In this lesson, we're going to focus on some of the shortcuts to know whether you have congruent triangles or not. So specifically in this one, we are going to focus on side, 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 and side, angle, side. So the idea of congruence, we've talked about this with dealing with rigid transformations. We've also talked about this in that section, this last lesson, with congruence, where we talked about how they need to have the exact same size and the exact same shape. And we said that they need to have congruent angles and congruent sides. So when we talk about congruent angles and congruent sides, in that last lesson, it was focused on corresponding parts. So basically, how do the parts of each triangle match up to the parts of the other triangle? So in this section now, we're going to introduce some of the shortcuts for dealing with triangles. So how much of this information do you really need to know in order to determine or prove that the triangles are actually congruent? So how do we prove that triangles are congruent? There's 5 key methods, I guess, and ultimately, I mean, what the information is utilizing is it's saying that all of the angles are congruent to all of the other angles, all of the sides are congruent to all the other sides, but you actually don't have to have all that information. So you actually only need to know that all 3 sides are congruent to all 3 sides of another triangle. Or you can know just side and an included angle and another side, or an angle and then an included side and an angle, or angle, angle, side, or hypotenuse, leg. So we'll focus on the first 2, side, 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 and side, angle, side. So anytime you have a triangle, if you have 3 sides of one triangle and they are congruent to 3 sides of another triangle, then the 2 triangles will always be congruent to each other. And I challenge you to try to take 3 pieces, 3 sticks, for example. If you take 3 sticks and you lay them out, you will only be able to construct one triangle with those sticks. It's not like the example where we talked about, it's not like the example where I talked about how if you have 3 congruent angles to 3 congruent angles, how we that object and make it larger. It's not like that. If you have 3 sticks, you will only be able to make one triangle with that. You're not going to be able to come up with another type of triangle. So side, side, side. So right here I'm showing you the tick marks to demonstrate that AB is congruent to DE, BC is congruent to EF, and because of the 3 tick marks here, you know that AC is congruent to DF. Now we can set up our congruent statements. Our congruent statements showing that AB congruent to segment AB congruent to segment DE, segment BC congruent to segment EF, and so on, which ultimately leads us to triangle ABC congruent to triangle DEF, based on side, side, side. How are triangles congruent? In this example here, if I split these 2 triangles apart, we wouldn't know that this middle piece is actually congruent to itself. We wouldn't know that for a fact. But since these 2 triangles are pushed together and they share this middle segment, I know that on this triangle on the right, all 3 sides are congruent to all 3 sides on the triangle on the left. And the only reason I know that is because the 2 triangles are pushed together and they share this side. So when they share a side, that actually has a special name. So since each triangle has side BD, then I know that BD is congruent to BD, and that has a special name. It's called the reflexive property. When they share that side, I know that that side is equal to itself, and that is called the reflexive property, and this should be a triangle symbol here. Triangle ABD is congruent to triangle CBD by the side, side, side postulate. So the reflexive property of congruence, it's when you have a segment, when a segment is congruent to itself, or an angle is congruent to itself. Side, angle, side. Now the angle needs to be an included angle. That's the biggest part about this one. So if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then you know for a fact that the 2 triangles are congruent to each other. So when I talk about included angle, I'm talking about the angle that is between your 2 congruent sides. That is the included angle. So angle A is congruent to angle D. That is the included angle because it is between the sides that are congruent. So our congruent AB would be congruent to DE. Angle A would be congruent to angle D. AC would be congruent to DF. Therefore, I can conclude that the two triangles are congruent. Here's my congruency statement. Triangle ABC is congruent to triangle DEF because of the side angle side. So which one is the, these two are the sides. That means the included angle would have to be angle G. On our next triangle, if these were my two sides, then the included angle would have to be this top angle, angle I. And then on the last one, it would be angle H. Name the included angle here. So if I was referencing segment YE and segment ES, the included angle for those two segments would be angle E. If it was ES and YS, the included angle would be angle S, because that's the one that falls between them. And then YS and YE, here's YS, here's YE. The angle that falls between them would be angle Y. That is the included angle. How are these triangles congruent? When I look at these, I need to be able to state side, side, side. Well, I can't state that because I don't know that this is congruent to this. Can I state side, angle, side? Since these two triangles are pushed together and they share this middle segment, I know that this is congruent to itself. Therefore, I can state side, angle, side, and that's because of the included angle, and that's because they share that middle segment, the reflexive property. That's right, side, angle, side. On our next one, side, angle, side, we can state that again, and that's because we know that these two angles are congruent, and that's because vertical angles are congruent. And on the last one, we can still state side, angle, side, and that's because the included angle here is congruent to this included angle because of vertical angles. So therefore, I can state side, angle, side. All right, that finishes off the lesson on your two congruency statements of side, 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 and side, angle, side.